In this problem, we're dealing with locks, 4-digit locks. And so basically what we can do is we can say that we're dealing with 4 tasks. That is, we have to choose the first number, the second number, the third number, and the fourth number. And so we can say the ands will replace with a multiplication. And then we stop and say, well, what are the options for each? So we're looking at lock A first of all here. Now, with lock A, we're able to repeat our digits, which is probably pretty typical for a lock like this. That is, when we look at the first number, we say we can choose 0, 1, 2, 3, 4, up to 9, and that is 10 different options. 1 to 9, and then the 0 in addition to that. So then what we can do is we can look at the second digit, and since for lock A we're allowed repeating, that means that if we had a 2 for the first digit, we're sure 2 is still an option for the second digit. It doesn't eliminate that as an option. So we still have a full 10 options for the second, 10 options for the third, and 10 options for the fourth. So for lock A, we can say, well, how many different possibilities? Well, 4 zeros, so 10,000 possibilities. So certainly it's pretty secure, right? There's to do a lot of guessing in order to end up with the right code by probability there. So let's look at lock B. Lock B, same kind of situation in that we have 4 tasks. We have to do the first number and the second and the third and the fourth. So the first number, certainly we have 10 options. The 0 through 9, nothing different there. But the second number, what we would have to say is that, well, for instance, if we chose a 2 for our first number, then a 2 is no longer an option. So we have 1 less digit available for the second number. So we only have 9 options for the second number. And in the same way, we look at the third number and we'd say, well, 2 of the digits have already been used. So we only have 8 and 7 for the last digit. And so when we multiply those all together, we get 40. Okay, so we take a look at that, and we, from a probability point of view, we would like more options. We'd like more alternatives. It makes it more difficult to guess what the right code would be. And so we can see that lock A has almost double the number of options, so certainly more secure with lock A.